live. There we go. Okay, today, 1, 22, 21. So our objective is talking about linear functions. But first, let's talk about what a function is. So, define a linear function. It's where every element of the domain is paired to exactly one element in the range. Okay? Or when we were in Algebra 2, we said the same thing but a little bit differently. We said every x value has only one y value, okay? So I'm saying the exact same thing except for you have to start getting used to math, what we call math language, okay? When you go to college, when you take a math class in college, they're going to use the math words. I'm going to use the common English words, but I'm going to use both in here so you guys get the idea. So the domain means x's, doesn't it? The domain really means x's, and the range means the y's. So I'm saying the same thing. Every x value has exactly and only one y value. Every element in the domain is paired to exactly one element in the range. Okay. So before I do a whole lot, I flip my page over and just watch. So if I have y equals 2/3 x plus 1, I mean, just a real quick sketch. Just watch. You don't need to write this down. Just watch. You know this graph looks something like this. You guys agree? Everybody agree with that? That is a function because every x value has one y, every x value has one y, every x value has one y, every x value has one y. Right? You guys agree? So it's definitely a function. So here's what we do. Since it is a function, we just write this. Instead of writing y, we write f of x because it is a function, so we can say it's a function. Okay, instead of y equals, we're going to say f of x equals. Okay? Now, some things that are not functions, a circle. So if I graphed a circle, that's not a function because this x value right here has two different y values. The circle is not a function. In fact, there's a thing called the vertical line test. Remember that from last year? The vertical line test says if I can draw a vertical line anywhere, and if it hits the graph in more than one place, it's not a function. Okay, we learned this last year. Okay, a parabola is a function because the same thing, every x value has exactly one y value. And a parabola, some kids are confused because then they think, but we're just talking about a vertical line, okay? A sideways parabola would not be a function, right? Okay, you guys got the idea of a function? Now let's go back to our notes. So, example 1, it says f of x equals 2/3 x minus 12. Okay, well that could be, or we could write it as y equals 2/3 x minus 12, but it's the same thing. It's more specific since it is a function. We'll just use f of x. So the x has to be the same variable as what's in here, okay? And we'll talk about story problems eventually where we'll change these variables, okay? Now, this is a question. Find f of 3. So it's a question. It says in words, in English, it says plug in 3. That's all it says. F of 3 just says plug in 3. Plug in 3 for the x, right? So f of 3 would be, f of 3 would equal 2/3 times 3 minus 12. Okay, that's all it is. And then I'll simplify it. And I'll get f of 3 is equal to, let's see, 2 minus is negative 10, okay? Trust me, you can do the math. It's negative 10. Okay, so what is this, f of 3? So if I plug in 3 as an x, and I get negative 10 as a y, it's just a point. That's all this is. It's just a point. So this is a point, 3 comma negative 10 on the graph. plug in 3 for x. We get an answer of negative 10, which is a y value, so it's just a point, okay? Now, f of 0, it's a question. What are we going to do with the 0? Plug it in. So I'm going to say f of 0 is equal to 2/3 times 0 minus 12. So f of 0 is just negative 12. And again, that's a point. That's a point. It's a point 0, negative 12. Pretty easy? Now, this one's different. Hopefully you see that it's different. This one's different. It says f of x is equal to 0. So instead of writing f of x, we're going to write 0 right here. F of x is 0. So I'm going to write 0 right here. So I'm going to go ahead and rewrite this one as 0 equals 2/3 x minus 12. Because it says f of x equals 0, so let's write 0 right here. Now let's solve for x. So solve for x plus 12, right? Okay, let's add 12. We're in pre-calculus, so I'm not going to do it Landon's way anymore. Landon likes to do this in 2 steps. I like to do it 1 step. I like to just multiply by the reciprocal. So if I multiply by 3 over 2 and multiply this by 3 over 2, it's just faster. So x equals, okay, 2 goes into 12. 6 times 3 is 18. Okay. So this is also a point, but it'd be a point at 18, 0. Okay. Now, what is a constant function? Cruise control. What is a constant function? It's cruise control. When you get into your car, and I assume most of you drive, right? And you hit cruise control, it stays a constant 60 miles an hour. I assume 60. You're not doing 80, are you? Not on cruise control, though. No. Probably not. So if you take a look at the graph of constant function, here's your miles per hour, here's your distance, right? So constant function stays constant. It never changes. The slope of a constant function is 0 because your rate never changes. You with me? So any constant function is always a horizontal line, and it's whatever the y value is. Good? So that's constant function. So one way to write that is you can write it as, so constant function would be f of x equals, and they like c because c is any number. As an example, we could have let's see, f of x equals 60. That could be 60 miles an hour. Stay straight up, but they are horizontal graphs. So a constant function is a horizontal graph. Yes, Malachi.
I just wrote domain is all the x values in a function.
Yes, you're ahead of me. You're totally correct. So let's put that down. Domain is all possible x values in a function. Nice job. Totally correct, Malachi. You're ahead of me. I like that. You remember this stuff, don't you? And what about the range? Yep, all possible y values. Okay, not too bad, right? Not too bad at all. So let's take a look at our first example. Okay, so we're going to do a story problem, but it's not hard. Okay, so railroad tracks will expand because they're made out of metal, right? Does that make sense? They're made out of metal, so they're going to expand and contract with how hot or cold it is. It's got to be a function because there's no way at any particular temperature that the track would be 2 different lengths, right? There's no way, so it has to be a function. It's going to be temperature, length. I mean, it can't be, it's like a different universe, right? So it says, okay, so here's our model, and let's go ahead and fill in the chart. So we're going to put in 0, we'll plug in 10, and I'm just going to use my calculator to do some of this work. It's not too hard, but the 0 is easy. If we plug in 0, I get 10. I plug in the 10, let's see, I'm going to go my 0.000 times 10 plus 10, and I get a 10, oh, I forgot to put, oh, that's because I forgot to put in the 1, didn't I? Try that again. That should be a 10. Should be a point. There is something wrong with my equation. Put a 1 right there, you guys. Put a 1 there. Dang it. Right, it is a linear equation, yeah. So if I put in 10, 0.000, whoops, 0.001, it is linear, yeah. 1 times 10 plus 10, there we go, 10.01. Put in 20, and it should be a 10.02, but we'll do it 0.001 times 20 plus 10, and I get a 10.02, 10.03, 10.04. I got to fix that. I got to put the 1 in there. Okay, so let's graph it. So, hopefully you've learned this in science, but there is a control variable or dependent variable and independent variable, okay? So my independent variable was these numbers. Plug these in. My dependent variable is this, because these numbers, these answers were dependent on these numbers. Say it again. These answers were dependent on these numbers, okay? So 0, 10, 20, 30 go on my x-axis because they're my independent variables, okay? So I'll put those in. Go ahead, get the ruler. And I'm going to go ahead and label this. So this is temperature in Celsius. I'm going to go 0, 10, 20, 30, 40. Okay. And we're going to go length in meters. And I'm going to do a 10. Let's see, 10.01, 10.02, 10.03, 10.04, because I need it to fit, right? So I've changed my scales, but I can do that. I can use different scales. And you're right. Well, then it is definitely linear, so we're going to graph, and we know it's linear because of the exponent, right? So if I graph it in there, I'm going to have a point at 10. We learned the other day that if it's linear, it's straight, and this is straight, right? Okay. It stops there. I need it to stop there. Okay, so domain. What's a reasonable domain? So a reasonable domain is my x values, right? So a reasonable domain is from 0 is less than or equal to my temperature C, which is less than or equal to 40. Okay, so that's set notation, but I want to teach you a new way to do this. Okay, I want to teach you interval notation, which I like much better. Okay, interval notation looks like this. It's easier to write. You guys agree? Bracket 0, 40 is interval notation. Interval notation. Okay? A bracket means it equals it. A bracket means it equals. If it didn't have the equal, we'd use a parentheses. Okay? Have you seen this before? Anybody seen this before? I think I taught it maybe a little bit last year. we do it last year? Who knows? It's all been a blur, right? Okay, and then the range, we'll do the same thing on the range. The range could be from 10, because the range is the y's, less than or equal to the length, which is less than or equal to a 10.04. But in interval notation, I would just go 10, comma, 10.04, and that's it, okay? How am I doing? I like interval. You guys are going to really, interval notation is better. It's easier to write. Okay, turn the page. Okay, senior class, Cameron, here we go. You guys know we raised over $21,000 on parking? Holy smokes. We're going to have a party. We will, Cameron, I promise, okay? Yep. Okay, the senior class, gas rented, boy, I got to learn how to type. Senior class rented an ice rink to raise money. They'll charge $5 admission, but the rink will cost $200, okay? Write a linear equation to model this, okay? So if we want to call it as far as income, I'm going to say income. I'm going to say my $5 per person. Go N, and then I'm going to go minus 200, okay? You okay with the minus 200? All right, so is this a function? Well, let's graph it, okay? So let's graph this. I'm probably going to need to go and do this. I might go by, what do I want to go by? Tens maybe? I might go by tens. Yeah, because otherwise the 200, I might even go, I got to get all the way to 200 here, so I might go by 100s. I might go by negative 100, negative 200, 100, 200, right? So I'm going to put a point here at negative 200. I got to be careful with my slope. Okay, I got to be super careful with my slope. If I go by fives, 5, 10, 15, 20, 25, 30, right? If I go up 5 and over 1, it's not going to show. I could go up 50 over 10, and that might work. Same number. You guys see that? Same number, but it's going to make it easier to graph, right? So if I go up 50 over 10, puts me here, up 50 over 10, and I'm going to go ahead and graph my line in, okay? Probably should use different, wish I'd used different scales, but okay, it's going to work. Okay, I'm going to do one more thing on my equation, and I'm going to rewrite my equation as I of n. I rewrote it in function notation, okay? So I of n, I've got income with respect to the number of people that show up, okay? Does that see the function notation? Income with respect to the number of people is equal to 5n minus 200, okay? Now, reasonable domain. Cameron, how many kids are in the senior class? Maybe 100?
Yeah, about 100.
About 100. So let's just say we've got 100 kids. 100 kids. So domain. Domain is the number of kids, right? So hopefully everybody in the senior class is going to show up. So what do you think? Domain. 0 to 100, right? So I'm going to say my domain is going to be 0, 100. There's my domain. The range is my income, right? I know my lowest income is negative $200. It's bad income, right? Nobody shows up. They go to the wrong place. Whatever, right? Negative 200. And then What's the most amount of money we're going to make? Maybe. How can we find out?
Show up.
How can we find out?
5 times however many people.
So let's say everybody shows up. Okay, Olin, I like that. So let's say everybody shows up. How can we find out how much money we made? Yeah, Malachi, what would I do?
Okay. Multiply, the admission times the number of people, which would be 500,
Right, so we're going to put the 100 into our equation, right?
and then once you get 500, and then subtract 200. The answer is 300.
There you go. You guys agree with them? So if 100 people show up, so the income for 100 people, plug in the 100, 500 minus 200 is 300. Good man. There you go. So that's my reasonable range as far as money, okay? Now the break-even point. What's the break-even point? Yeah.
Minimum they need to make money.
Right, so all of a sudden we get just enough people that we don't owe any money, but we haven't made any. So that means my income would be 0. You guys agree with that? So I'd have a 5n minus 200. And let's solve it. Plus 200 plus 200. Divide by 5. What do you get, 40? So we have to get at least 40 seniors to break even, okay? All right? So, last one. Next one is how many tickets must they sell to make $400? Well, set the income equal to 400, right? Okay. Plus 200 plus 200. Okay. 600 divided by 5, what's that, 30? No, 120. 120. So in this case, we'd have to bring our boyfriends and our girlfriends. We'd have to bring extra people, right? Which means that would change our range and domain, right? Now, what if the rink could hold only 240 people, right? So if the rink could only hold 240 people, we just plug in the 240. Let's see what this means.
Thank you.
You're welcome. Five times 240 minus 200. That's a 200. We'd make $1,000. So if I were a senior, yeah, Genevieve.
Wouldn't that change the
My goodness gracious, I was going to talk about that. Good job. Yes. So then, if we can get more people in, we'd make more money, and then we would change our domain and our range, right? So what we'd really need to do, like a real problem is we'd have to find out what is the capacity. And most places have a capacity. Of course, now with COVID, capacity is a little bit different these days, but let's just assume it's non-COVID. We go to the rink and we say, okay, what's the capacity? And they tell us how many people can come in. And Genevieve, you're right, that would change our range and domain, wouldn't it? Okay, all right. That's all I have for today. That was a good question. Come on, stop recording. Stop recording.